So what evaluating means is we're going to be plugging in a value for a variable and then simplifying it. And then translating, kind of like what you would think translating means. A lot of, when you translate from one language to another, you're making it make sense in one language from the words in the other. Same thing, math's like its own language. Okay, so first, down at the bottom there, or kind of in the middle of the page, a variable. A variable is just a mystery number. It's something we don't know. Typically, we use a letter. That's the most common thing you're going to see. Okay, really, you could use anything. It's just something to let us know that we are missing a number there. Really, you could plug in, like it shows there, a question mark, and use that as a variable if you want. It's just showing that we have an unknown, and we need to solve for it. We need to figure out what that unknown is. Okay, so it's not very common to see anything other than a letter used as a variable. All right, so down here, the most simple of translating, we see something like 6 plus 6, you might see the word plus. There's other words we'll look at when we get to the back side, where you say more than or added to. That might be adding. Minus, what's another word you think could mean minus? Subtract. What about take away? Less than, anything like that. And we'll look at how you can translate that here in just a minute. Anytime we have the coefficient written right next to the variable, that's multiplication. Okay, so times is probably the most common you've seen before. What's another word that means the answer to multiplication problem? Starts with a P. Product, yep, that works. And division is the one that there's really not that many words that you can use to say divided by. Most of the time you'll see divided by. That's about it. All right, so over at the top of the right, an algebraic expression. It's a sentence, if you will. So an algebraic sentence. It has to have two important things. It has to have at least one variable, and it has to have no equal sign. If you put an equal sign in it, it's no longer an expression. It becomes an equation. So think of an expression as like an equation with no equal sign. So those are all examples of the algebraic expressions. When we just have a variable, no equal sign. You can have more than one variable, but at least one. So the simplest part today is evaluating. So all evaluating means is if we're given an expression, in this case 13n, and I tell you to evaluate it when n equals 3. All that means is go take 3 and go plug it in for n. Now it's a good habit to get into when you plug it in, put it in parentheses. Because this does happen. I've seen people do this. They go plug in a 3 there and they write 133 and say, oh, that's my answer, 133. It's multiplying. But if you put it in parentheses, you won't make that mistake. So then we multiply 13 times 3, and we end up with 39. So that is all evaluating is. So if you move down to the bottom, look at those examples. We have 6y when y equals 2. Go plug in 2 for y. Now we got 6 times 2, and we get 12. You go over to the right, 11 minus p when p is 9. We'll plug in 9 there. So 11 minus 9, and that gives us 2. So we evaluated 11 minus p when p is 9. Next row down there, 2 plus x squared when x is 4. So 2 plus 4 squared. And then we simplify that. So what would 4 squared be? 4 times 4? 16. There we go. And then, yeah, you were saying the final answer. And then 2 plus 16 gives us 18. And then over to the right there, this is one that has two variables. If you have two variables to evaluate it, I got to give you two values, one for each variable. So x plus 2y when x is 5 and y is 3. So x is 5, y is 3. So then we have 2 plus 3, which gives us 6, and 5 plus 6, and we end up with 11. Okay, so that's all evaluating is. Taking an expression, You have to be given the value of the variable. If you are not, you can't evaluate it. And then plug it in and simplify. Questions so far? All right, so a little more in depth with translating. All right, so some key words that can mean these different operations. Addition. So we've all heard sum, right? That's one we hear a lot when we start learning addition. Plus. And. And does mean add most of the time. If you say, it usually comes with another word. Like you'll see combine 2 and 3. Well, combine 2 and 3 tells me to add 2 and 3 together, right? Okay, total. If you're asking for a total, that generally means add. If you get the total for what you're paying for at the store, they're adding up all the things you bought. More than. That's when you see quite a bit for addition. Increase by. So all those words would tell you that we need to add whatever we were talking about. Addition definitely has the most words as far as any of the different operations. Subtraction, there's a lot less that can be used. Difference, you've seen difference probably, right? Less than, decreased by, and those can be a little tricky how you write them. We'll get to that in just a minute. And then minus. Those are our keywords for subtraction. And then multiplying, times, product, we talked about that on the last slide. Multiply by, of, and there should be another one there besides each, because you're going to see it quite a bit. You see per or each. If I tell you that these shoes are $100 per pair, and you're buying 5 pairs, you would do what? Find your total. Multiply, right? 100 times 5. So per pair, that's going to tell you to multiply. Same with each. If I said these shoes were $100 each, it means the same thing. Those keywords tell you to multiply. And like I said, division, a lot less words you can see. Most of the time they're going to say something about divided by. Quotient, you've all seen quotient, right? That's the answer to the division problem. So there's the only keyword you might see with division. All right, so using those to now translate from an English sentence to a math sentence. So if we have 8 more than a number n, and when you read these, when you see where it says a number, a lot of times it makes more sense if you just cross those words out. So if I cross out a number, 8 more than n, that looks a lot simpler to write. So more than means what operation? Add. So 8 more than n, 8 plus n. Or you can do n plus 8. Okay, across here, half of m. Couple ways you can write this. I sent it down there, right? Of up here tells us we are multiplying. So we could do 1/2 times m. Since that keyword tells us to multiply. But you wouldn't be wrong if you wrote m divided by 2. It would mean the same thing. That would be half of m. Alright, so I mentioned above that less than is the tricky one to write. What operation does less than? Subtraction. If you have less than something, I have less money than you, we're subtracting to find the difference. But with less than, you have to write it backwards. 7 less than b. The tendency is people to put 7 minus b. It's got to be b minus 7, because we're taking away 7 from the b. So when you see the words less than, that is the only time you need to write it backwards from how you're reading it. It'll never happen in any other situation. Less than is when that happens. So this would be opposite. B less than 7. 7 minus b. And if you ever get stuck on which way to write that, instead of saying b, plug a number in there, and you'll figure it out. Like if I say 7 less than 10, how would I find my answer? 10 minus 7, right? So it'll tell you what order to write that in. Okay, next one, very similar to this one up here where it said half of m. This is 1/4 of a number a. So 1/4 times a, or you could write A divided by 4. Either one of those would work for that. Okay, next one, now we have two operations. You could have more than one operation in a problem. So the first part, more than, what operation is that? Addition. So I know I'm going to have 5 plus something. So 5 plus 3 times a number x. So 3 times x. And you end up with 5 plus 3x. The next one tells us the quotient. What does quotient tell you to do? Divide, yeah. So we know we're dividing something. The quotient when the quantity 10 plus a number x, so they're telling you to take 10 plus x, is divided by 2. So that becomes 10 plus x divided by 2. Next one, a piece of ribbon r feet long is cut from a ribbon 8 feet long. So now we're taking a situation, kind of an application problem, figuring out what is happening to this ribbon to figure out what operation we need to do. If I'm cutting a ribbon, am I making it longer or shorter? Shorter. So does that sound like adding or subtracting? Subtracting. So if the ribbon is r feet long, piece of ribbon r feet long is cut from a ribbon 8 feet long. So the ribbon started how many feet? 8. And we are taking away r. Whatever you're cutting out, that's what we're subtracting. And last down there, now we're going to go the opposite way. Now when you go the opposite way, there's a lot of different ways you could write it, because there's a lot of words we could use. So if we have 10 plus 4x, you'd say something like 10 increased by 4 times x. So there'd be one way you could write it. There's really kind of endless ways, probably at least 10. You could say 10 more than the product of 4 and x. So when you're going from the algebraic sentence and you want to write it back into an English sentence, more than one right answer. You've got a lot of words to choose from in our language that mean the same thing, right? You just know there could be, I'm going to put more examples possible. All right, so move it over where it says classword. I want y'all to just go 1 through 8 there, and then we're going to talk about 9 through 13 after that, because they're more applying it to situations. So 1 through 8.